Okay, guys, so remember Hess's law we can use because enthalpy is an extensive property, meaning it depends on how much you have, and then also because we can flip the equations. So for this one, we are trying to make this final equation here. And so we need the 3 equations above to add up to that. So what we're going to do is first make sure that everything is on the right side. So here I see my first thing is NH3. And when I look up, NH3 is in equation 1 here. But there's only 2 of them and I need 4. So I'm going to double this whole equation, which also doubles my delta H. And then I'm going to bring it down. So I've got 4 NH3. And then I have 2 N2s, 6 H2s, and then my delta H is 92 times 2, which is 184 kilojoules. Okay, so I've used my first equation. So next I am looking for oxygen. I see oxygen in a couple different places, so I'm going to hang on to that one for a moment. So I need to go back and finish that one. But this one here, I've got 4 NOs. So I see NO in equation number 3 here. It's on the correct side, but it's not the correct amount. So I'm going to double this and rewrite it. So I've got 2 N2s plus 2 O2s gives me 4 NOs. And when I double that is negative 360 kilojoules. Okay, and then my last thing, I need 6 waters on the product side. And I see water only in equation 2. It's on the wrong side and it's not the right amount. So I'm going to multiply it by 3 to make it 6. And I'm going to flip it. So I'm actually going to multiply by a negative 3 for my delta H. Okay, so I've got, let's see, I'm going to flip it. So I've got 6 H2, 3 O2, and that is going to give me 6 H2Os. And when I do that calculation, I end up with negative 1,716 kilojoules. Okay, so let's go in and make sure that everything cancels the way it should. So I see 2 N2s on the reactants, 2 in the products, good to go. 6 H2s in the reactant, 6 H2s in the product, good to go. Nothing else cancels, so now I'm going to bring it down. So I have 4 NH3s. I'm going to add together my oxygen. So 2 plus 3 gives me a total of 5 O2s. And then I have 4 NOs and 6 H2Os. So my equation down here in blue matches the equation number 4, this one here, up above, which means that I've rearranged correctly. So now I just need my delta H value. So to do that, I'm going to add those pieces together. And what I end up getting is negative 1,892 kilojoules. So this is an exothermic reaction. Okay, so you guys, there's kind of 3 things that I want you to do today. So hopefully you've turned in your specific heat lab. If you have questions, I'll be back Monday. So you're going to start by doing 2 more of these Hess's Law practice problems. So it's numbers 12 and 13 in your thermochem packet, and that we've been working in all week. Then you are going to watch the entropy calculation video. So yesterday I said there's one more way to calculate this entropy value. So you're going to do that. You are going to need a gold sheet. It should be sitting up front. It has standard enthalpy, entropy, and Gibbs free energy values in it. Once you've done that, you're going to try a couple of those problems, so numbers 14 and 15 in your packet, and that should essentially finish out your thermochem packet. Remember, that's your practice packet. We'll go over those problems on Monday. Your assignment for the weekend then is to finish some more in your book assignment. And if you turned it in, unfortunately, I have your book assignment. So you can do these problems on your own sheet of paper. Just make sure that you do all the parts of the problem. You show your work and that you are organized. And then it's going to be super helpful for you to box in or circle your answers so that I can really see where that information is coming from or what I should be grading. Okay, I will see you guys on Monday. As always, email with any questions.